Let's take function f of x equals x to the power n, and we'd like to find f prime at x. So we set up the problem. It's the limit as h goes to 0 of f of x plus h minus f of x divided by h. Then we put x plus h into the formula for the function, and we'll get x plus h to the nth power minus x to the nth over h. And at this moment we need to simplify x plus h to the nth power. That is, we need to multiply it out. So what is nice, the formula for the multiplied out expression of x plus h to the nth power was already done by Isaac Newton, and he found that the nth power of the sum of x and h is equal to x to the nth plus n choose 1 times x to the power n minus 1 times h plus n choose 2 x to the power n minus 2 h squared plus higher and higher power of h. So that the next to last term is n choose n minus 1 x to the first h to the n minus first power plus h to the power n. What we can see that the last group of terms, starting with the third one and up to the last one, all of them contain h squared. I will state it here. And secondly, we're going to use it later. Now, on the other hand, this n choose 1 coefficient is actually equal to n for any n. And as I said above, as I said a few minutes ago, all the terms but the first two contain h squared. So we'll go ahead and abbreviate everything that contains h squared as h squared times mass. So we can factor out h squared in every term in here. So if we do that, we're going to be left with some nasty expression. So now we can use all of that to continue the calculation. So by the previous discussion, we've got that x plus h to the nth power is equal to x to the nth power plus n x to the power n minus 1 h plus h squared times some nasty expression. So we continue with the calculation. We left at this limit as h goes to 0 of x plus h to the n minus x to the n over h. Now we put that expression in place, and we immediately notice that x to the n could be cancelled with that minus x to the nth power. So that we're left essentially with two terms, n times x to the power n minus 1h plus h squared times something rather complicated. What we're going to do now, we're going to factor out h, and we're going to end up with h multiplied by n times x to the power n minus 1 plus h times something complicated. Now we can easily cancel h in numerator and denominator, and we have that we are left with the limit as h goes to 0 of n times x to the power n minus 1 plus h times some expression, and into this expression we can put h equals 0. And we'll get n times x to the power n minus 1. This is usually called the power rule. Let's work on the calculation of derivative of sine x. As the definition of the derivative suggests, we start with the limit of the difference quotient. So derivative of sine x is the limit as h goes to 0 of sine of x plus h minus sine x divided by h. Then we use trigonometric formula on sine of x plus h. That will be equal to sine x cosine h plus cosine x sine h. And so we can continue calculation on the next slide. Okay, so we keep going. So instead of sine of x plus h, we use the trigonometric identity. And we get the limit as h goes to 0 of sine x cosine h plus cosine x sine h minus sine x. What we'll do next, we'll rearrange the terms and move this negative sine x in the middle, like that. Then we notice that the first two terms have a common factor of cosine, rather sine x. So we can factor out sine x out of the first two terms. So we're going to be left with cosine h for the first term. And then there is negative 1 in front of sine x here. For the next step, we'll split this big fraction into the sum of two fractions and have the limit as h goes to 0 of this first part, sine x times cosine h minus 1 over h, plus the second fraction, cosine x times sine h over h. And that then could be split into the sum of two limits. The limit as h goes to 0 of sine x times cosine h minus 1 over h, plus another limit as h goes to 0 of cosine x times sine h over h. What we know that the limit of sine h over h as h goes to 0 is actually equal to 1. And then the limit of cosine h minus 1 over h as h goes to 0 is actually 0. So we'll have that, well, before we do that, we can factor out sine x, and we can factor out cosine x. And then remember that the limit of cosine h minus 1 over h is 0, and the limit of sine h over h is also equal to 1. So we have sine x times 0 plus cosine x times 1, which is cosine x. That's the derivative of sine x. Now, to find derivative of cosine x, we do a similar calculation. We set up the derivative as the difference quotient. That's the limit as h goes to 0 of cosine of x plus h minus cosine x over h. And then we again use trigonometric formula. Cosine of x plus h is equal to cosine x times cosine h minus sine x times sine h. And we can continue the calculation. So, now we can actually continue calculating the derivative of cosine x. For the next step, we put what cosine of x plus h is equal to. That's cosine x times cosine h minus sine x times sine h, although that's still minus cosine x. We again move negative cosine x in the middle, like on this formula, and then again notice that cosine x happens to be a factor in the first and the second term, so we can easily factor it out into cosine x times cosine h minus 1. And we still have sine x times sine h for the next term. Then we can split that into difference of two fractions. Cosine x times cosine h minus 1 over h minus sine x times sine h over h. Then the limit of this difference is the difference of limits as h goes to 0 of cosine h times cosine h minus 1 over h minus the limit as h goes to 0 of sine x times sine h over h. And the next to the last step is to factor out cosine x out of this first limit and sine x out of the second limit. So since this function doesn't contain h, it's legal to factor it out, and sine x doesn't contain h, it's also legal to factor it out. Now we remember that the limit as h goes to 0 of cosine h minus 1 over h, this one is actually equal to 0. And the limit as h goes to 0 of sine h over h, this one is actually equal to 1. So we get cosine x times 0 minus sine x times 1, and the end result is negative sine x. Now we are going to work on a library of shortcuts to find derivatives, and those shortcuts are usually called rules of derivatives. One shortcut that we have already gotten is this derivative of x to the power n, and it is equal to n times x to the power n minus 1. It is true that we proved the formula only for positive integers n, but that same formula holds true for any real number n, including fractions and negative numbers. There are some other shortcuts that we will find useful. Derivative of some constant, like here, of a constant function, is always 0. Derivative of x is equal to 1. And the power rule, derivative of x to the n, is n times x n minus 1. Then derivative of the sum of two functions is equal to the sum of the derivatives. Derivative of the difference of two functions is equal to the difference of the individual derivatives. And derivative of some fixed number times a function is equal to fixed number times the derivative of the function.